In this video, I'm going to break down CSWA exam part 2 assembly. In my previous videos, you can find part 1, which is part design, and also there is drawing part. And if you want more of these exams, you can check out my YouTube videos, or you can go to my community. There's a link below, and I have full preparation for the CSWA, CSWP, and other SolidWorks tools and techniques. Now, what we have here in the part 2? So we have the assembly like this one here, and this assembly consists of 3 parts. So we have 1, 2, and 3. So what do we have to do? We have to put together this assembly, and then we have to calculate the center of mass relative to the coordinate system 1. So here is the coordinate system 1, right? On this edge here, x, y, and z. So that's very important to know. Also, what's very important to know, where is our coordinate system? So as we can see, this is our main coordinate system here. So we have to put our first part here. Then what we have to do, we have our second part. And this second part, as you can see, here we have 30 degrees between this and this, right? Here's the 30 degrees of this one here. And then this one here, we have 60 degrees. And also what we have here, 20 millimeters distance. So those are the few details that we have to know. And now what we're going to do, we're going to create an assembly file, and we're going to start putting these together. Okay, so let's just create an assembly file. And first, what we're going to do, we're going to show where is our coordinate system. Okay, so that's the first thing we want to know. Here it is. And now we can go to the insert components, and we can choose part 1. So now what are we going to do? We're going to just put our part 1 here. And now what do we have to do? We have to make coincident all of the planes of the part 1 and all of the planes of the assembly file. Now, before we do so, we have to go here to the Feature Manager Design tree. And here we have part 1, and it says it fixed. So we can just go with a right click and go and float. And now we can move this in the space. Now we're going to use tool mate. So we're going to now make coincident between all of the planes. So we have front plane of the assembly and front plane of the part 1, right? So that's going to be coincident. Then we have coincident top plane of the assembly and the top plane of the part 1. And then also go with the right plane and right plane, and let's click OK. So this is how we fix our part 1. That's everything about a part 1. Part 2, so let's go with the part 2. We're going to just put it here. And now what we're going to do, we have to insert this one to this hole, right? So we have to use 2 mates. So the first mate will be concentric between this and this one here. So that's the concentric. The second mate that we're going to use is coincident between this face and this face here. Let's click OK. So that's just the first part of this part 2. Now what we have to, you see, we can rotate this. Now we have to put that on the 30 degrees. But before we do so, I want to go to isometric view like this, because 30 degrees is between this face and this face here, if I remember correctly. So what are we going to do? We're going to go to the mate. Then we're going to go here to the degrees, and we're going to choose, we have to unselect this. We're going to choose this one and this one. Let's click OK. Now let's just put that in isometric view. Let me see if this is a good angle. And if we check out this isometric view, this is not what we got. There's only one thing that we have to do. So let's go to our assembly. Let's go to the isometric view. So we're gonna go here to the mate, right click, edit feature. And the only thing that we're gonna do, we're gonna just go here, flip dimension, like this. Let's click OK. So this is our part 2. Now we have to go with the part 3. So let's go to the insert components. Let's go with the part 3. So first thing that we have to do, we have to put that one here, right? So we need here concentric, like this. So that's just the first part. Super simple. The second part that we have the distance, which is 20 millimeters between this part and this one here. That's 20 millimeters. And the third thing that we have is an angle, which is 60 degrees between this face and this face. So we're gonna go flip, not like this. We're gonna actually put here 120 like this. That's what we are looking for. So this is pretty much what we want. And now the only thing that you have to do, we have to insert the coordinate system. So we can go to here, reference geometry, coordinate system, choose this edge, and for the X, we're gonna choose this. For the Y, we're gonna choose this. And we're gonna just flip here directions like this. So we have X, Y, and Z. That's it. And now we have to calculate the center of the mass relative to this coordinate system. So let's go to the mass properties. And we have 3.41, 92.80, 11.75. So let's see results. Now, as you can see, this is not correct. And this is not correct because we have to do one thing. So let me show you. So let's go to the mass properties. Report coordinate values relative to, we have to choose coordinate system 1. So we have minus 122.20, minus 35.10, minus 130.20. So let's see if this is correct. Yeah, this is it. We got a good answer. Now let's go to the part 2 of this exam. In second task, we have to make a few changes. You can see we have to completely get this one to the different direction. Then here we have 120 degrees. And I made a mistake on the previous drawing. I put here 60 degrees. Actually, it was 120 degrees. So that's my mistake. And here we have the distance 120 millimeters. So the first thing we have to do, we have to flip this. As you can see, it's completely opposite side. Then we have to put here 120 millimeters. And here we have 120 degrees. So let's do this. Let's go to the assembly. So the first thing that we have to do, we have to flip this one completely different direction, right? So for example, if we go here to the concentric edit feature, we have here mate alignment. We can go here with anti-aligned like this. This is what we are looking for. Okay, so that's the first thing that we have to do. Then we have to go here and we have to fix the angle. So let's go here, angle. We're gonna delete this, clear selection. We're gonna choose this one again and this one here. We're gonna go 120 and we're gonna go flip dimension like this. Let's click OK. And now the third thing that we have to do, we have to fix this distance. So we're gonna first actually delete this distance. And now we can move this here. Now we can go to the mate again and we can choose the distance here. So we're gonna go distance, it's gonna be 200 millimeters. So we're gonna choose this one here and this one here. And let's click OK. This is not good. If I remember, it's 200 or it's 150. Let's check out. because this doesn't seem correct. Okay, it's 120 millimeters actually. I don't know why I got 200 millimeters. So let's go to the edit feature. And here we have 120 millimeters, like this. Let's click OK. Let's click OK. Let's go to the isometric view. Like this. Now let's calculate the center of the mass relative to the coordinate system. 1 minus 132.55 minus 53.11 minus 130.20. So let's check out if this is correct. Yes, this is correct. This is within 1% of the correct answer. You can have mistakes within 1% because these mistakes are based on the software, is not up to you. So this is the CSWA Part 2 assembly. And if you want the full exam, full preparation for CSWA and the CSWP, I help hundreds of people pass these exams. Just click the link below, join the community. You're going to get access to the full course and full exams.